And what we want to talk about first of all is what is slope. And the slope is normally designated by the letter M, and it's rise over run. And if you have 2 points, x1, y1, point 2 is x2, y2, then when you calculate the slope, the rise is y2 minus y1 over x2 minus x1. Now, you can do it this way. You can do y1 minus y2 over x1 minus x2. The only difference when you calculate it these 2 different ways is, for example, one will be a positive number, like this one will be a positive number over positive number, then this would be a negative over negative. So if they turn out to be positive. If it were, if the answer would be negative, then one of these 2 would be negative, and if, for example, if this were positive and this were negative, then over here, this would be negative and that would be positive. It'd still be a negative number. It will work out no matter which ordered pair you put in the first position and which ordered pair you put in second. But you must notice that if you put y2 in the first position, you must put x2 in the first position. If you put y1, you must put x1. Because if you do it this way, it would be incorrect. You did y2 minus y1, and then put x1 minus x2. What would happen is the sign of this whole thing would be opposite the sign of these 2. So if you had a positive slope, and you did it this way, you'd end up with a negative slope. Likewise, you can't do y1 minus y2 and then do x2 minus x1. Both of those are incorrect. Those are typical errors that people have. And you see, if you have a positive slope, as you go left to right, it's going to go up, right? If you do it incorrect and you do it negative slope, then you would say it's going down. And that would be just absolutely wrong. Now, other typical errors that people will do, they'll put y2 minus x2 over y1 minus x1. And that's not correct. They'll take the difference of the ordered pairs in your numerator. So be sure that you practice these and get it straight in your head how to set them up and do them. Okay, so what we're going to look at then is on your section 4.4, we'll look at number 2. And this is the way you do these problems. You go P1 is 2, 3, and P2 is 5, 1. Now notice that this would be x2, y2, and this would be x1, y1. Pardon me, I did that wrong. This is x1, y1, and this is x2, y2. because it's P1 and P2. So now when I do my slope, it's going to be y2 minus y1, x2 minus x1. I would suggest until you're really comfortable with it, you write the formula out so that you make sure and get the right numbers. So y2 is going to be what? 1, and y1 you're going to subtract 3. x2 is 5, and x1 is 2, so you're going to subtract 2. So now 1 minus 3 in the numerator is a minus 2, 5 minus 2 in the denominator is 3, and what you can do with that is you can write that as a negative out front like this, if you would like, or you can write it as 2 over minus 3. Makes no difference. Those are all the same. Now, when you write it in this manner right here, that's saying you're going down 2 for every 3 you go to the right. When you write it this way, that's saying you're going up 2 for every 3 you go to the left. So this is just a generic number that doesn't have an indication of how you're moving, rise and lower. But it's still written correctly. Typically, when you're doing slope, you would either write it this way or you'd write it this way. Okay, I'm going to do 12. P1 is 4, 1, and P2 is minus 1, minus 2. So now we're going to calculate the slope. And for y2, we're going to pick, notice it's minus 2. This is x2, y2, and this is x1, y1. And so you see I'm picking minus 2 for y2. y1 is going to be 1, so I'm subtracting the 1. x2 is a minus 1, and I'm subtracting 4. So the numerator is a minus 3, and the denominator is a minus 5. Now when you look at that, you're going to move left 5, down 3. Typically you would write it, the minus over minus would be a plus. Written that way, it says you're going to go right 5, which is the run. The bottom is the run, and up 3. So it makes no difference which way you go. You know, that's a way to say it or calculate it. P1 is a minus 2, minus 5, and P2 is a minus 4, minus 1. So if you're going to do slope, it's y2 minus y1 over x2 minus x1. Now notice the y2 in this case, this is x2, y2, and this is x1, y1. The y2 is that minus 1. The y1, so I'm going to subtract, and y1 is a minus 5. So be sure that you get your signs in right. x2 is a minus 4, and x1 is a minus 2, so you're subtracting x1. Now then, the numerator is a minus 1 and a minus 5, so that's plus 5. This is technically minus 1 plus 5 over minus 4 plus 2. So this is going to be a plus 4 over a negative 2. Now you can read that as up 4, left 2, or left 2 up 4. Or you can reduce this and put a minus 2, and now minus 2, there's understood that in the denominator it's 1. So that's going to say right 1, down 2. You could also write this as 2 over minus 1. So that's a left 1 up 2. Your slope would be, this would be the way you write the answer right there. Any questions on that? 20. The math does not do us any good unless we're able to interpret it and put it in, some sort of form. And it says the graph below shows the number of people subscribing to a sports magazine whose popularity is increasing. Find the slope of the line between the 2 points shown. So the first thing we have to do is find the slope of the line. Notice the first point, point 1, is 2002. That's number of subscribers is 580, probably 580,000 or something like that. And then the second point is in 2007, it's 850, probably 1,000. It says, as a matter of fact, it says number of subscriptions in thousands. So that's what it is. So now what we have to do is find the slope. Well, the slope is going to be y2 minus y1 over x2 minus x1. And realizing that this is x1, y1, and this is x2, y2. So when we substitute in there, y2 is 850,000 minus y1, 580,000. x2 is 07 and x1 is 02. So that numerator is how much? 270,000, right? And the denominator is 7 minus 2 is 5. So that it's saying 270,000 subscriptions, right? And in 5 years, right?
Yeah.
Now, typically, you would reduce this down, and so you divide the 5 into 270. What would you get? 5, 4.
Yeah.
That'd be subscriptions, and what's understood to be in the denominator? 1, isn't it?
Yeah.
So now, it says, what is the meaning of the slope?
So there's 54 subscriptions per year.
Okay. The average increase in subscriptions per year has been 54,000 subscriptions. Right? Now, it might have been more or less in years, but on average, it's going up 54,000. So if you were a publisher of that magazine, what would be your expectation next year? How many subscriptions would you have? How many did you have this year?
Oh, so next year would be around 90,000.
Okay. This year you had 850,000 subscriptions. Your expectation is next year you would have how many? You'd have 54,000 more because it's been increasing at a rate of 54, right? So you would add 54,000 and you'd have 904,000. So what would you want to be if you were the publisher of this magazine? There would be some expectations that you would have. That magazine is going to be published on paper, right? So then you probably better do what? You better get some more paper ordered, right, than what you had this year. You better buy some ink, more ink, right? You better make sure that you got the capacity to print that many subscriptions if it's a monthly subscription. You better make sure that your printing presses are capable of doing that, right? You would use historical information to project out, and then if you were the editor or manager of the paper, you would want to be doing some planning on how you're going to make sure that you actually make the stuff available to the people that want to buy it. Okay, 24. It says, graph below shows the relationship between the distance and the time for the 10,000 meter run for the world record by Arturo Barrios. I don't know what. Anyone know this person? 1989. No sport, no running enthusiast. So what they have is they're saying that the starting point P1, and notice it's time in minutes. So the starting point horizontally is 0 minutes and 0 meters, right? The ending point is 27.14 minutes and 10,000 meters. And they say find the slope of the line between the 2 points. Well, what we have is this is going to be x1, y1, and this is going to be x2, y2. So our slope is going to be y2 minus y1, x2 minus x1, which is 10,000 meters minus 0, 27.14 minutes minus 0. 10,000 meters, 27.14 minutes. Now, according to my calculation, if you divide that out, you have 414, about, for purposes, I don't know, it's not 4,000. 414 This is meters. So what is 414 mean? What does 414 mean? You're forced to write an explanation as a sports writer, and you have this information, and you're going to use it to explain to people what. Okay, so this gentleman ran 414 meters per minute. Now, does that mean that from beginning to end he ran that speed? No, because he started off and he accelerated out, right? And he might have run faster and slower, because you've seen them when they run the thing to go around, and they say this time around they ran the lap in so many minutes. The next lap they run it in, so many minutes, different than the previous one, and it varies throughout the race, right? And then they'll talk about if they can keep up this rate, on the lap, they will be able to run it, so long. So they're calculating what? Averages, right? And they're trying to figure out what this person is going to be able to, how long it's going to take. And this is just an average of what he ran. So, if he sprinted at the end, or if he got tired and he didn't have much left, his average at the end is going to be less than the beginning. But overall, he's went 414 meters a minute. So, any questions about that? Okay, the next thing is, it says the American National Standards Institute states that the slope for a wheelchair ramp is 1 in 12, cannot exceed 1 in 12. Now, you have a nursing home, and you're managing the nursing home. What are you going to have to do? Or have somebody do? Every ramp in your nursing home is going to have to be measured, right? If you want to expect to get federal money for payment for people who stay there. This may be a hypothetical, but it'd be real if you were managing. Now, you go out and you measure this ramp on number 26, and you find that this ramp says it's 12 inches high and spans a distance of 170. So I'm going to draw this out. Which one of those things on that ramp is 12 inches? Which one are you going to label 12? Okay, the vertical part, right? This is going to be 12 inches. What's going to be the 170? Is it up the ramp, or is it this one, or is it this one? Okay, it's this one. Now, the thing you better make sure that if you send somebody to measure it, that they measure it the same units, right? If they measure it horizontally in feet and vertically in inches, then what do you got to do? Everything's got to be in the same units, right? If you measured it vertically 1 feet, that 170 you got to convert it to feet, right? Because your units have got to be the same. So now, how are you going to figure out whether you're in compliance? How are you going to figure out whether you're in compliance? Okay, so you're going to say the slope of my ramp is 12 over 170. Now what are you going to do? You got to compare that to 1 over 12, don't you? How are you going to compare it?
X 2 minus X 1. And Y 2 minus
Okay. I guess that would be one way to do it. You could hypothetical. If I understand what you're talking about, you're saying a ramp that would comply with this would have to be 12 here and 1 here. Is that right? Is that what you're saying?
I guess.
How would you compare the 12 to 170 as 1 to 12?
Convert the inches to feet.
Yeah, but the only thing is you'd still have to compare. If you did inches to feet, then this would be 1 foot right here. The 12 over 70 would be 1 foot, and then horizontally it would be 12 into 170. What would that be? 12 into 170. 112, 50. Is that 14? No. 50. No, it'd be 14 point something feet. And then this would be 1 inch, you'd have 1/12 of a foot. 1/12 over 1 foot. That'd be kind of hard, right? You can make the problem harder. Well, what you're going to have to do, this is what you're going to have to do. You're going to have to get least common denominators with these two. So you're going to have to prime factor this 17. Prime factoring it, the 2 out of 17 would be 2 times 85, right? And then that 85 would be 5, would come out of 85, and you'd have what? 17. So 170, this is the prime factorization of 170. 2 times 5 times 17. All right? The 12, prime factor, a 2 would come out, and you'd have 6. Then you go 2 times 2 times 3. Do you understand prime factorization? 2 times 2 times 3 are prime numbers, and they are all factors of 12 that multiply to 12, right? 2 times 2 is 4, 4 times 3 is 12. These 2, 5, and 17 are prime numbers, such that when you multiply those together, 2 times 5 is 10, 10 times 17 is 170, they give you 170. Now the least common denominator, you would have to have a 2 in that least common denominator, because there's 2 in each one. You'd have to have another 2 because there's a 2 over here. You'd have to have a 5. You'd have to have a 3, and you'd have to have a 17. This is called the least common denominator. So that means both of these fractions right here. $12 over 170 and 1 over 12 would both have to be set up so that they have these factors in it. The 170 is actually 2 times 5 times 17. Now, if you look at the prime factors there, what is that denominator lacking? A second 2, right? It's lacking a 3. And if it had a 2 and a 3 in it, it would have the same factors as that. So you can put a 2 and a 3 in there if you multiply the numerator by 2 times 3, right? Because 2 times 3 over 2 times 3 is 1. You have not changed the fraction, you have simply changed the numbers that it represents. Now, what about 12? 12's prime factors are 2, change the color, are 2 times 2 times 3. Now, if you look up here, what does that denominator lack? It lacks a 5 and a 17. So you have to multiply the numerator times 5 times 17. Now, both of these denominators, this one and this one, are identical, correct? If you multiply this out, you get 2 times 3 is 6 times 12. What number is that? $72. 5 times 17 is what? 85. Now, is 72 over this denominator greater or less than 85 over that denominator? Which is the smaller fraction?
72.
This, right, the 72. So this one is less than that. Are you in compliance? Your rise is 72 in whatever length that is. The compliance rise is 85,
Oh, yeah.
right? In other words, this distance you have just converted, both of you have in that denominator, this distance here is 2 times 2 times 3 times 5 times 17 for both of them, right? Now, on this vertical, the compliance is what?
55 over.
Okay, so the compliance is going to be at 85, right? Your number is what? 72. So your ramp, when you run it out that far, would be something like this. And it says you have to be less than that. Are you in compliance? Yeah. So you'd have to be able to do that if you're going to be able to determine whether you're in compliance or not.